In a group of 50 students, 40 study mathematics, 32 study physics, and each student studies at least one of these subjects. Use the Venn diagram to find how many students study both. And then, if a student from this group is randomly selected, find the probability that he or she does either of those two things. So we're going to start by drawing a Venn diagram. First thing to think of or to recognize is that each student studies at least one of these subjects. That means there's nobody in the soup of our Venn diagram, so it's just two overlapping circles. We have mathematics, and we have physics, M for math, P for physics. The total needs to be 50, but if you add 40 and 32, you'll recognize that that is, in fact, more than 50. So if I subtract 50 from 72, that'll give me the extra students. Those are the students that take both subjects. So 22 are shared math and physics students. If 22 are taking math and physics, then that means that we need to subtract 22 from 40 to get how many only take math. And we need to subtract 22 from 32 to get how many only take physics. So there we have completed the Venn diagram to find out how many students study both. The answer is 22 study both. It's not enough to just have the Venn diagram. You actually have to answer the question too. If a student from this group is randomly selected, find the probability that he or she studies mathematics but not physics. So in this particular example, we want the students who study math but not physics. So that is these guys over here. That's just 18 out of however many there were. It was 18 out of 50. Remember, the question isn't how many of those students, it's the probability of the students. So it's the number divided by the sample space, which was 50 in this case. If you just gave me the answer 18, you would not get credit. For part 2, studies physics given that he or she studies mathematics. So this is our new conditional probability. So we want the probability that a student studies physics given that he or she studies math. So if we use our formula packet or we turn back in our notes to look for the formula, what we're going to see is we need the probability that a student takes physics and math divided by the probability that the student is taking math. So the probability that a student takes math is everybody in this whole math circle. So the point of a conditional probability is that we have now changed our universe from the 50 students that we started with to just being these 40 students who take math. That's our new universe. And then we need the intersection of physics and math students. That is these guys here in the football. That color is terrible. And we end up getting 22 out of 40. So our answer is 22 out of 40 is the probability that they study math given, or study physics given that they study math.